My name is Dil, and today I will present the clustering algorithm known as spectral clustering, which is a powerful technique that uses graphs and linear algebra to discover groups in complex datasets. Or in other words, datasets that are not exactly linear, they are non-linear. We create a similarity matrix between all the data points of the dataset. One common choice is the Gaussian similarity function, and this is the formula for a similarity matrix for this Gaussian kernel. Basically what it does, it creates a similarity between some points. For example, if this was our dataset, we will create similarities like these ones. And it will create a similarity matrix called S, which is the similarities. Given this similarity matrix, in other words, we can say the adjacent matrix, we build the Laplacian matrix, which helps us understand the structure of this graph we are creating. As we know, a graph will be this kind of distribution because we are translating our dataset into graphs. So we first calculate the degree matrix, which is diagonal, and then subtract the similarity matrix, which was calculated. This is called the normalized Laplacian. We can also apply the normalized Laplacian, which will be L equals D elevated to minus 1/2 times L times D elevated to. Next, we apply eigendecomposition to the Laplacian matrix we obtained, which was L equals D, the degree matrix, minus the similarity. So, this is textbook linear algebra. We get the eigenvector equation and we get the eigenvalues. This will help us to get the eigenvectors. And, well, that will be the step where we apply linear algebra. If you wanted to see this graphically, well, first, imagine this is our original dataset. We can put like a line to divide the clusters because they are interconnected. We can put a line here, we can put a line here. But if we apply this spectral method with the Laplacian, we will get something like this. This will be the first cluster, and this one will be the second cluster, given the projection of the eigenvector. And as we can see now, we can place a line right now, and it will get a real cluster. Finally, we apply k-means, which is the most famous clustering method because this is a new lower dimensional set. This works because of this, because we made a projection of this using the Laplacian, and this will now work because it is now linearly separable. Well, this is like the whole spectral clustering on a nutshell, and I hope you like this video.